Okay, I'm going to briefly present some performance results of 2 trials that we have carried out, testing an enzyme preparation with mostly alpha-galactosidase and chyelanase activities. Indeed, the alpha-galactosidase we tested here is the same one that David tested in their in vitro studies. And we do it in fattening pigs, focusing on, or willing to focus on the effect on soybean and rapeseed meal. Okay. Well, just as an introduction, and to have a little bit a picture, seeing this, we may assume that indeed there's a potential room for improvement in terms of the energy that we can get from different key ingredients. Here I have shown corn, wheat, and then the ingredients we were mostly interested: soybean, rapeseed meal, and here we show peas that were also tested in the vitro studies. So considering the cost of the energy in the diets that we used in our animals, we wanted to test specifically the effect of these enzymes in the provision of energy from these ingredients that initially are mostly devoted to provide protein to the diets, but there are an important source of energy also to these diets. Also, very briefly, when we refer to anti-nutritional factors in legume meals, we can talk about oligosaccharides, specifically about alpha-galactosides with raffinose, estatiose, verbatiose. This is the structure of these molecules, with a disaccharide of sucrose with different galactose added to the glucose. These oligosaccharides are soluble but are not digestible, so they are a source of flatulence and discomfort to the animal, also affecting to maybe affecting to the intake and to the digestibility of the diet. And also, of course, we have these non-starch polysaccharides, cellulose, phytic acid, trypsin inhibitors, and also resistant starch. But we were willing to focus on this part because, as I mentioned, these alpha-galactosides and also the sucrose, which indeed can be degraded by endogenous enzymes at the intestinal level, but there are some works that have described that the presence of sucrose may originate or pre-originate the presence of galactosides by the addition of monosaccharides of galactose to this sucrose. So it's interesting also considering this as an element that may contribute to the presence of these oligosaccharides. So the fact that these are soluble make them maybe more prone to the action of some enzymes added externally, so in order to degrade these components. So the objective of these studies were to test the effect of combining these alpha-galactosidase and endochelonase on the performance of growing fattening pigs, because mostly we have some data on poultry and wing piglets, but not indeed for growing fattening pigs, and it's certainly interesting that to some extent we can see some effect because of the impact that has in the cost of the production of pigs, having an effect in growing fattening pigs. So we tested 2 doses of this enzyme preparation, and a standard one, and another a bit lower, according to our experience in commercial commercial trials. And then we also, in a second experiment, well, we tested the product on top as a control, and then in a second experiment, we restricted the net energy, a 2% restriction, in order to evaluate the specific effect in terms of energy availability. So we carried out the trials with 72 pigs per trial, half male, half female, individually housed and blocked by body weight and sex. All the animals weighed around 26 kilos and 10 weeks of age, and we used these specifications of diets for the different physiological stages of the animals, according to standard specifications for this production in Spain. And the animals were weighted, the intake registered, and we calculated the feed efficiency. And for the second trial, we also went to slaughter to evaluate carcass yield. Okay. For the first trial, this was the diets that were used, the composition of the diets. So in this first trial, we tested wheat and barley, and the addition of soybean with a control with only soybean, and a diet where a 10% of rapeseed meal was added, substituting partially the soybean meal. A 2x3 factorial design was used in a randomized block design. So we tested 2 different levels of enzyme, as we mentioned, and 2 different diet compositions, depending on the presence or not of rapeseed meal. So as results, we observed that there was an increase, a numerical increase of the body weight of the animals at the end of experiment before going to slaughter, with no significance, but it seemed to be dose dependent for the case of soybean meal. So we are talking about an increase of about 2 kilos with respect to control. When we evaluated the soybean meal plus rapeseed meal diet, we observed that with respect to the control and the higher dosage, we found similar results indeed, but unexpectedly we found that with the lower dosage, the weight was much higher than expected. So 113 with respect to the control of about 107. So these results were not expected. When we go to the feed intake, we see that for the soybean meal, the feed intake is similar, no difference in this case. With respect to the soybean meal plus rapeseed meal, we see that there's an increase in the feed intake, not statistically different, but seems to be dose related with respect to the enzyme addition. When we go to the feed to gain ratio, to the conversion, we see that numerically seems to be an improvement when the enzyme is added. And here we observe that statistically we found a clear improvement of the feed conversion, which is linked to the increase of weight, a significant increase of weight for this treatment. Honestly, we are not able to clearly precise why this happened, although generally the results seem to show that there's some effect of this enzyme combination at the end of the studies. So we went to a second trial where, in order to focus mostly on the effect of this combination of enzymes on the soybean meal and the rapeseed meal added to the diet, we mostly used corn, some wheat in the feeds for the grower, last grower phase and the fattening stage. but mostly corn. So trying to focus on the effect of the enzymes in the meals, in the level meals. In this case, we tested just the higher dose of the enzyme, so with a positive control, and then we tested, as we mentioned, the 3% reduction, a lower energy diet, also with a control and the treatment with the enzyme. With respect to results, we saw, similarly to the results in the previous trial, that weight was numerically improved when the enzyme was added. This is the control, so indeed was quite similar to the previous trial. But when a reduction of energy of 3% was tested, we observed that for the treatment where the enzyme was added, we saw that the results were similar to the control and to the group where the enzyme was added on top. So it would be what we were willing or were expecting. But then again, here we observed that the final weight for the group that had the energy restricted, but without the enzyme, was higher and significantly higher. So we tended here, observing the results of a feed intake where there were significant differences too. We hypothesized here that the animal in this case was not receiving the lower energy diet, was not providing enough energy with respect to the other diets, so the animal had a greater intake. This would not be happening here because of the enzyme, so the energy provided was suitable. In this case, the animal would be having a greater intake, and this would result in greater deposition of protein in the animal. That's one hypothesis that we can provide here. We see in the basal diet here again, as in the previous trial, that numerically, although no differences were obtained, the feed to gain ratio was improved, and in this case also, or at least there were no differences. But of course, these results here add a lot of noise here, so we are not sure about what could be happening here. And with respect to carcass yield, we observed that with respect to the positive control, when the enzyme was added on top, we observed an increase in the back fat thickness. So we think that this would mean that indeed the enzyme allowed to have more energy available for the animal in the diet, and this would explain these significant differences, and also consequently a reduction of the lean meat percentage in the carcass. But then here again, we see the negative control with the enzyme, where the results are similar to the control. So it would be what we would be expecting, and also similar lean meat percentage. But then with this treatment, where a reduction of energy but without enzyme was used, we see here a greater back fat thickness with significant differences with the treatment with the enzyme that we were not expecting. And as I say, we can only relate it to the increase in the feed intake that eventually added more energy or more fat to the carcass animal. Okay. So, as a conclusion, a numerical increase of body weight, lower feed conversion of fattening pigs was observed when a combination of alpha-galactosidase and chilenase were added on top to soybean, rapeseed meal-based diets. That a reduction of 3% net energy in the diet seemed to be compensated in the treatments receiving the enzyme. And in the negative control, a lower energy density might be counteracted by greater feed intake, as we have mentioned, and a greater protein deposition. And then the energy restriction was compensated by the enzymes, and similar carcass performance was obtained. In the negative control treatments, higher fat deposition might be due to much higher feed intake to compensate for lower energy density of the diet. And for the future, adjusted dose of these enzymes to diets with legumes other than soybean meal and combined energy and protein restrictions, I think that need to be explored. Also, the adjustment of the energy that we are using in our diets would be warranted to be evaluated according to the results, because maybe the energy provided to the animals is higher than maybe needed. But also a restriction in protein might be interesting in order to evaluate if this restriction in energy is compensated. It's something that we are willing to do in subsequent trials. And this is all.